In this session, we're going to take a look at data, what types we have to use, and how we use them. Data are the pieces of information that we keep track of things with when we're writing computer programs. They come in two different forms. One are called variables, and those are things that can change over the course of the program. The other type are called constants, and these are things that are fixed. So a variable, for example, might be the temperature in the room. It might be the number of people that have come into a venue, where a constant might be things like pi or the maximum number of people that could come into a room. There are really only three types of data that we need to keep track of. The first are things we count. So that would be things like the number of parts in an assembly, the number of people that have come into a venue, anything that we're going to count. The next are things that we're going to measure. These would be things like pressure and temperature, things that when we, as embedded system programmers, are looking out for, this would be stuff coming in from our sensors. The last type of data are called characters, and those are things that we read. So that would be text, so that would be information coming in from a file or characters typed in by someone at a keyboard. So if we're counting, we're using whole numbers, so we're going to use integers. If we're measuring, there is the risk of there being a partial value, so something like 1.52, so we're going to use a floating point number. And if we're reading, we're going to use characters, and sometimes we put those together into strings. When we're naming data values, we have to consider two things. First, the rules established by the governing body of the C programming language, and second, the conventions for the environment in which we're going to be programming. The rules are musts, the conventions are shoulds. Let's talk about the rules first. So, regardless of where your C program is going, we need to follow these rules. The first character of any variable or constant name has to be either a letter or an underscore. The name itself can contain lowercase letters, uppercase letters, digits, that would be 0 through 9, and underscores. No other characters are allowable in a variable or a constant name. So we could name something value either with or without this underscore at the beginning. One of the most important things to remember about C is that it's case sensitive. That means the variable name is not the same as name with a capital N or name written with a lowercase n and other letters capital. These would be considered three distinct variables or constants. Now for some of the conventions. The first is that every variable or constant name should describe what type of information it's going to store. This is going to make your code far more readable. For embedded systems, they ask that you do not start your variable names with an underscore. So up here, we would eliminate the underscore and just call our variable value. Next is that for constants, we're going to use all uppercase, and for variables, things that are going to change throughout the code, we're going to use all lowercase. So what we have defined up here is a variable, and we know that simply because it's all in lowercase letters. Sometimes if you're looking at other people's code, you may see multi-word names that are joined either by an underscore, or sometimes they would use first no underscore and then a capital N here instead of a lowercase n. Those are both acceptable under the rules, but for embedded systems, it's recommended that we join multi-word names with an underscore. And then finally, and this is one for those of you that have been programming in C before, is no variable in an embedded system environment should be less than 3 characters. And this includes loop counters. A lot of people are used to using I, J, and K as their loop counter variables, and you'll see that in sample code in your textbook, for example. But in embedded systems, because of the inability to search for an I, because it's found in so many other words, that it is far better to use at least 3 distinct letters for all variable names. Let's take a look at defining constants. And let's start by looking at the three examples that we have at the bottom. You can see that each of them starts with what's called a directive, in this case, number define. And we know when we see these, and usually they're right up at the top of our code, that we're going to define a constant or fixed value. Next, we use a space separator, and then we follow that by the name of our constant. So remember, constants are always in uppercase letters. So here we have size, multiplier, and separator. Then we have another space and the actual value. So size is going to take on a value of 3. Multiplier is going to take on a value of 7.25, and the F stands for a floating point number. And separator is going to take on the value of a slash. So we have a directive, the name of our constant, and the value of our constant. When we declare our variables, we need to do things a little bit differently. First of all, we need to tell it what type of information it's going to be. We had things that were counted, integers, things that were measured, floating point numbers, or things that were read, characters. So which type is it going to be? We can see down at the bottom, we have an integer value, we have a floating point number, and we have a character. So the first thing we're always going to see is a definition of which type of information we're going to store. Secondly, we need to give it a name. So our variable names are always going to be defined in lowercase, and we're always going to follow it by a semicolon. So a data type, a data name, and a terminator. Now variables are going to be defined preferably inside the function where you're going to use it. So C is broken up into a series of functions that all work together to do the whole. And inside our functions, we want to define the variables that are going to be used to do that particular task. We'll talk more about functions in Unit 4, but for now, understand that a variable should be declared inside the function where it's going to be used. Now let's talk about the keywords that we use to actually define it. We talked about int and float and char up to this point, but there are more. So let's talk about things that are counted. So these are the things that we're using whole numbers, and our default is integer. And we get a certain range, depending on whether we're on a PC or in an embedded system, and let's talk embedded systems here, from minus 32,000 and some up to positive 32,000 and some. And for most of the things that we're going to count, that's enough. But occasionally, it's not quite enough, particularly if we're doing some arithmetic with them. In that case, we'd need to go to a long. So you can see here, now all of a sudden our range goes from minus 2 billion and some up to about 2 billion. That's going to be enough for most of the calculations that we would want to do on an embedded system. Sometimes, though, we want to go the other direction. So if we know that an integer is going to be too big, we don't need to go from minus 32,000 up to 32,000. We can use a short, which gives us here minus 128 to plus 127. So what this means is how much memory is going to be used. An integer is going to use one amount, a short is usually going to use half of that, and a long is usually going to use twice as much as that. Now on some platforms, you're actually going to have a long, which even doubles a long. So you can see in an embedded system, there's no difference between a long and a long. But on a PC, you can see we can go from minus quintillion to plus 9 quintillion. And if you don't know what a quintillion is, that has 15 zeros in it. So you can see that in certain platforms, we can have a really big range of signed numbers. Now, when we're talking signed, that means we can have negative numbers as well. So you can see all of these, by default, go from a negative value up to a positive value. And that becomes very useful if we're doing arithmetic. If we're not going to be doing arithmetic, and all we're going to be doing is counting things, that means we don't need any negative numbers. So we're going to use what are called unsigned numbers. So here we can see we have an unsigned int, so we're putting the keyword unsigned in front of our regular keyword. So we have an unsigned int, which would be our default. We now go from 0 to 65,000 and some. So before, with assigned, when we went from minus 32,000 up to plus 32,000, now we're taking that same range of things, but we're putting them all as positive numbers. So from 0 up to twice 32,000 and some. We look at our unsigned short. We're taking that what before was minus 128 to plus 127, and now we're making those all positive, so 0 to 255. We have an unsigned long, which goes from 0 to 4 billion. Before, we went from minus 2 billion to plus 2 billion. And an unsigned long, which we're not going to use on an embedded system, but if for some reason we needed it on a PC, we could go from 0 to 18 quintillion. Pretty large number. Now let's talk about things that we're going to measure. So our default is float. So these are our floating point numbers. We can have decimal points. And with a float, you can have 6 significant digits, which gives us a range from 10 to the minus 37 to 10 to the 38. That's a pretty big range, and for most of the things that we're going to do on an embedded system, that's more than enough. But if for some reason it's not, and you need more precision or more significant digits, you can go to a double. And in fact, some of the math functions that are provided for us actually default to double so that they have that extra range of significant digits. So now we can go from 10 to the minus 307 up to 10 to the power 308. So you can see that's a big difference in range. And then again, if we needed even more than that, we can go up to 18 significant digits with a long double. Gives us a much bigger range, but most of the time, for the things we're going to be doing, we're going to use either a float or a double. Now let's talk about things that are read. So oftentimes when we're working with computers, we need words, we need to prompt the user, or the information that's coming in is a text file that we need to be able to get in and use. So we're going to use the keyword char, C-H-A-R, for character. And a character can store letters, whether they're uppercase or lowercase. It can store punctuation, so commas, periods, exclamation points, double quotes, single quotes, things like that. And it can also store non-printing characters like tabs and backspaces and the bell sound if you want that. So we can embed letters, punctuation, and non-printing characters into any character variable. The way it can do that is by using a numerical code called ASCII. And there's a normal ASCII set which has 128 different characters, which includes all our uppercase and lowercase letters and all our punctuation and some of the non-printable characters. And then we actually have an extended ASCII set which adds another 128, which contains a lot of the other non-printable characters. So using characters, we can put together words and strings, or we can treat them individually as, if we ask the user if they want to repeat something, they could say Y for yes or N for no. Then occasionally we'll use a special one that's called an unsigned char. And we're going to actually use this to store a small integer. So if the environment that we're using doesn't have the keyword short, we can use an unsigned char to do exactly the same thing. So we can store integer values from 0 to 255. So that's a kind of a neat little trick that we can use sometimes. Now, one of the rules that we have, and this applies to any programming environment, is that we cannot use a keyword, which is a reserved word, to name things. And there are a number of different keywords, so let's look at some of the main ones. First are the ones that define our different types of data. So we have our integer and float and character that we've just talked about. Then we have some aggregate data, and aggregate means group. And so we have a keyword struct. So we can't use that for a variable name. And then we have customizable data values, and they're defined using the keyword enum that stands for enumerate. So we can't use int, float, char, struct, or enum to define any of our, or as a variable name or a constant name. Then we have some keywords that are used to help us do things in our code. So we need to be able to make decisions. So we have a keyword if and a keyword else. so we can't name variables or constants that. Then we also have keywords that let us do things over and over again. So we have a while keyword, a for, and a do. So again, we can't use those. Then we have some that give us information about the code. So we have things about getting information into and out of a function. So we have a keyword void. It means nothing, but it means that we can't name a variable void. And we have keywords that let us share information between different parts of a bigger program, and that would be the keyword extern. So there are a few other keywords, but these are the main ones that we need to avoid as we're naming our variables. So we've taken a look at how to name our integers, our floats, and our character variables or constants, and we've looked at some of the limitations in terms of size and the use of keywords in naming those things.